Welcome again. In the previous videos, we have done the example 21 using alternative way as well as the chain rule. Now we will find the derivative of tan of 2x plus 3 with chain rule as well as by the alternative way. It's example 22nd in the 5.2 exercise of NCERT book. Let's start. So derivative of tan 2x plus 3. Firstly, what's the function? Now there are of course two functions again. First is tan and the second one is 2x plus 3. So f of x will be equal to v of ux. Simply what will be v? It will be tan t, and what will be u? It will be 2x plus 3. Okay, so now let's, just like the 21st example, just now denote the functions respective to the variable that is being used. Now v will be equal to tan t. This is a function in t, so v of t. Clear? Now what's t? T is a function of x. We call it as ux. What's that? 2x plus 3. You have to just do a simple thing, that the variable which is being used in the first function, that variable, the value of that will be depending upon x only. If v is depending upon t, then t will be ultimately depending upon the variable x. Okay, so just follow this simple step to learn what actually chain rule is. So now we are done with finding vt as well as ux. So what is df upon dx? That is dv upon dt and dt upon dx. Clear? So I am not solving it separately because I have done that in my previous video. So I am just solving it simultaneously in this step only. What's dv upon dt? Differentiation of tan t with respect to t will be multiplied by differentiation of 2x plus 3 with respect to x. Clear? Now the differentiation of tan t is secant square t, and differentiation of 2x plus 3, the differentiation of 2x will be 2 and the 3 will be 0. So we get 2 secant square t. Now what was t? That was 2x plus 3. Clear? This will be our answer. Let's solve it in the alternative way as well. Alternatively, we'll get, what's our fx? Fx will be equal to tan 2x plus 3. Then d of f with respect to x will be equal to ddx of tan 2x plus 3. Now what's the differentiation of tan x as a whole? We have to take tan x function as a whole. Okay, so tan x is secant square x, secant square. What's x now? What's the angle? That is 2x plus 3, and you will definitely derive 2x plus 3 with respect to, again, secant square 2x plus 3. What will be the differentiation of 2x plus 3? That is 2. The answer will be 2 secant square 2x plus 3. You can say clearly that there is no difference in both of the answers. So you can use any method. Sometimes, most of the times, the method to be used is not mentioned. So don't worry that if we are finding chain rule a bit complicated, you can use the alternative way. But just take care of the fact that if the method to be used is mentioned in the statement or not. So we are only left with our example 23rd now. In example 23rd, we have to differentiate sine of cos of x square. Now in this sum there are three functions. It's a composite function which is comprising three functions. Okay, we have only studied the chain rule for two functions. So before proceeding with this sum, just have a look at the chain rule of three functions. So if there are three functions, then the chain rule gets generalized as df upon dx will be equal to dw upon ds, ds upon dt, dt upon dx. First will be your w, second function will be your s, and third function will be your t. Clear? So there are three functions: sine, cos, and x square. So we will assign these values turn by turn, and if you want to derive f simply, so f will be equal to w of v of u of x. Clear? First function will be your w, second will be your function s will be a function of v, and then the function ux, that will be equal to t, that we are doing so far. Okay, so firstly let's assign the functions turn by turn. So just have a clear look on these steps which I am going to take. Okay, firstly we will start from the very first end, that is w of s will be equal to sine of s, because w is a function of s, and the subsequent variable to be used is s. Clear? Now w of s is sine s, because we have to derivate w with respect to s. Clear? Now we have used the variable s. Now the next one is we have to derivate s with respect to t. So our s of t will be equal to cos t. For the simplification and for just its identity with the original chain rule, they have used s is equals to v of t, which is equal to cos of t. Okay, so if s of t will be equal to cos t, it doesn't matter because we have to differentiate s with respect to t. So this is also correct. And last but not least, we have to differentiate t with respect to x. So what will be our t? T will be equal to u of x, which is equal to x square, or simply you can write t of x is equals to x square for your convenience. So you just have to remember the formula, and then you can assign the functions very easily, because when you have to derivate or differentiate w with respect to x, you will write like this: s with respect to t and t with respect to x. It's very easy. Once you remember the formula, then you can fill in the values. Now it's very easy. Differentiate ws with respect to s. You will get dds of w. What's the differentiation of sine x? Yes, you know it. That is cos s. Clear? Let's move ahead. Now differentiate s with respect to t. ddt of s will be equal to, what's the differentiation of cos t? You know this as well. That is minus of sine t. Now differentiate t with respect to x. What's the differentiation of x squared? That is 2x. Now multiply these three terms and you will get your df upon dx. Firstly dw upon ds, that is cos of s. Now simultaneously fill in the values. What is the value of s? That is cos t. Now what's the value of t ultimately? That is x square. Clear? So we have filled in the value of dw upon ds. Let's fill the value of ds upon dt. Minus sine t minus sine, what's the value of t? That is x square, and ultimately fill in the value of dt upon dx, that is 2x. So your complete answer will be minus of sine x square cos of cos x square multiplied by 2x, or you can write 2 at the very beginning. So this is your answer that you get by applying chain rule. So now let's apply the alternative way as well, and let's see if the answer comes up to be same or not. Alternatively, you have to simply differentiate the function, that is sine of cos of x square. Clear? Now firstly consider it as a whole function, that is sine of theta. Now what's the differentiation of sine of theta? Cos of theta. So write cos of theta. What's theta? Cos x square. Cos x square. Clear? Now differentiate theta again. So we will be differentiating cos x square again. Now consider it as a complete function. Cos theta, the differentiation of cos theta is equals to minus of sine theta. So we will be writing cos of x square, and cos theta, that is minus sine theta minus sine of x square. Theta will be again differentiated. So again differentiate x square, and you will get cos of x square and then minus sine of x square, use bracket also because it's a subtraction sign, and x square, the differentiation of that will be 2x. So now you can see the answer is same, 2x cos of x square and minus of sine x square. The answer comes out to be same by both ways. So I hope that you have understood how to apply a chain rule and how to solve alternatively. Now you can complete your exercise 5.2. Still, if you find any problem, feel free to share your doubts in the comment section, and before leaving, just don't forget to press that subscribe button in order to get new updates from my channel on a regular basis. Thanks for watching.